Today we're going to look at reflections within general functions. So we'll start off with a familiar function. Let's look at the quadratic graph. So I always like to call the positive quadratic a smiley face because it looks positive, it's a smiley face, it shows you the direction that the graph travels in. That's the function f of x. Now, if I was to reflect that graph in the x-axis, I usually call this the unhappy face because it's going in the negative direction, so it's a sad face. Now, this is actually the function, let me write that, positive y equals x squared. This is actually the function minus x squared. Now, what's happened here is this graph is exactly the same as this one, except it's being reflected along the x-axis, where the x-axis is the line of reflection or the mirror line. Now, if we're going to generalize this, every graph can be reflected along the x-axis just by changing the outside of the function to a negative. So, for example, if the graph y equals f of x is going to be reflected, it becomes y equals negative f of x. And that just generalizes. So I could do that with any function. I could do it with a cubic graph. So if I'm going to draw a cubic graph, draw a nice positive cubic graph. Positive cubic graph, y equals x cubed, looks like that. If I reflect that, I just put a negative in front of it. It then looks like this, which is a perfect reflection in the x-axis, and that's the line of y equals minus x cubed. And you can adapt this to almost any function. You need to make sure that you are familiar with what those graphs look like. So you need to know cubics, quadratics, reciprocals, exponentials, and square root graphs. Obviously the linear goes without saying. Let's have a look at how we reflect in the y-axis. So for this one I'm going to draw an exponential graph. So I'm actually going to make it a bit bigger. I'm just going to do 2 to the power x. 2 to the power x is a good one. Now we should know that exponentials have one intersection on the y-axis. It's usually, this one's at 1, because 2 to the power 0 is 1. So this is the graph of y equals 2 to the x. Alright, now what I'm going to do is I'm going to reflect this along the y-axis. So it looks like this. I'm going to do it as I can. It still cuts through 1 and goes like that. Obviously this particular graph never ever reaches the x-axis. So there's an asymptote on the x-axis. But this is actually the graph of y equals 2 to the negative x. Now, if I'm going to apply this to general function form, what we say is to reflect the graph of y equals f of x, so any function. What we have to do, and remember this is a substitution game, the reflection in the y-axis is f of negative x. And you can see here that if I substitute in the place of x, I get negative x. And that really applies to any function. I'll just do one more example when I clear some space. I'm going to talk about the reciprocal graph now, because if I was to draw the reciprocal graph, so that's the graph of y equals 1 over x. If I do that, it looks like this. Okay, obviously there are certain key features that you need to be aware of. I always suggest you put a couple of coordinates on to show that it's the graph of 1 over x, just in case it looks different from 2 over x, 3 over x, and so on and so forth. And the equations of the asymptotes, which on this graph are just y equals x and y equals 0 and x equals 0. Now, if I reflect this in the y-axis, it looks like this. Now, what you'll notice is it's also the same as a reflection in the x-axis. So let's just apply the function notation. So if our function is 1 over x, and let's suppose I wanted to reflect it in the y-axis, all I'm going to do is find f of minus x. Now remember it's a substitution, so we sub in whatever, wherever we see x, we sub this in, so I get this, which is actually the same as if I was to apply the general function transformation for the reflection in the x-axis. So let's do the x-axis. So f of minus f of x is what we're going to do. We're going to put minus and then put 1 over x. These two are actually exactly the same. Okay, and that's just applying the rule. That's everything you need to know about reflections within graphs.